Hey, welcome to another adventure in old code. It has been such a long time since I filmed, probably pushing 2 months now. I guess life just got in the way. Curious how the dead of winter leaves one with lots of times to do adventures in old code, and yet when the spring rolls around, there's no time at all. That and the fact that this is what my room looks like that I used to film in. So we've moved rooms and we'll see how this one does for us. Anyway, today we are going to look at a program I wrote many moons ago called Pong. Yes, it is that Pong. Joey's Pong game, January 22, 1999. All right, here we go. 1 or 2 players. I will go 1 player. Normal or customized. Learn how to spell previous, Joey. Okay, normal. Leave ball trail. No. And that is Pong. And that is going very fast. Let's figure out what we can do to slow that down. Is there no slowdown? There's no Okay, well this is the game loop, it looks like. So I'm just gonna put an empty for loop. Go like that. Okay, let's try this. 1, normal, no. Oh my, now I can't even see the ball. I think I know what's going on. What palette functions and everything? This looks intriguing. Okay, let's... Oh, I see. My speed. What is my speed? X speed. Y speed. Okay, I'm going to decrease my speed by 10. That should help me. Okay, normal. No. Still not going. Okay, but you get the idea. Whoa. What if I leave ball trail? Okay. Whoa. I need to get this into a place where I can actually run the game and have some fun. Let's maybe step through this code and see if we can't figure out how to fix it. So I'm going to open it up again because I don't want to screw anything up. All right. Think of Pong. There's a 2-player version, but let's figure out the 1-player version first, and we'll figure out how to slow it down, and then I'll give a better demo for it. So, okay. Joey's Pong game, January 22nd, 1 week before I turned 17. We've got 2 X's and 2 Y's. Okay. 2 ups and 2 downs. I'm assuming U and D are up and down. They're all... Well, these 2 are strings, and these 2 are integers. Okay, 2 element arrays, random number generator, and this... Oh, wow. Okay, well, I know what this is. This is another inline function, but instead of taking 1 value, this takes 3 values and does a calculation and spits out a single number. So this is to figure out your different colors. Now, I'm not sure why I didn't just use the regular 16 colors that were available to me. I must be going into a different screen mode. Oh no, screen 12. Interesting. Okay, well, we'll come back to this function and why I'm actually doing this when we get to it. Okay, we're randomizing the timer and going into screen 12. Now, U and D definitely are up and down. The first element is the up and down arrow keys. So I assume the U and D, the second element in U and D, are for the second player's up and down, and we'll probably set them to W and S or something like that later on. But the first player up and down are the arrow keys. Input 1 or 2 players, in 2 players. Okay, and if you chose 1 player, we do 1. An aptly named subroutine. Now, this entire game of 1 player is all done in one big subroutine. So there's not going to be much branching into other subroutines, which is unfortunate. Okay. Okay, B equals 0, whatever the heck B is. Palette 1, comma, function B00. Okay, so what this palette is doing, I think this is probably the first time we've seen this. So this is a graphics statement that changes one or more of the colors in the palette. So the explanation is this. If we go to screen, which we've gone to lots, we'll go here. Now, screen 12 is 640-480 graphics. We're very familiar with that. We have an assignment of 256,000 colors to 16 attributes. So at any given time, you have 16 buckets to use. Each bucket contains a color. You have 16 available colors to use at any point. And those 16 colors together are called a palette. And usually, if you just use the default palette, you get the regular 16 colors, where one is, I can't even remember now, it's been 2 months since I've shot a video and been outside of QBasic. 2 is green, 3 is a cyan, 4 is a red, 5 is magenta. 1 is blue, I think. Anyway, those colors have been predefined into the default palette, but there's no reason why you can't say, hey, I want to take some of those buckets and put different kinds of colors in, because we have 256,000 colors to choose from. You just only have 16 of them available at any given time. So the way you do that is you define a function. And I'm not sure if I had color. It's here somewhere. I remember palette. No, I'm going back. Here we go. Details. Okay, so this is how the palette command works. Palette 3, comma 2. Then the color 3 is now changed to color 2. Now color 3 was cyan. Now it's changed to whatever 2 is. You say, well, why the heck is that? That doesn't. That's not very helpful. It is helpful. Here we go. Okay, so when your monitor is VGA, you can actually have 256,000 colors. And the way you pick a color is you pick a blue value, a green value, and a red value. And for any given one of those values, each between 0 and 255, you plug them into this formula and out comes a single number which defines one of the 256,000 colors. So blue between 0 and 255, green between 0 and 255, and then red is between 0 and 255. So you have 255 times 255 times 255 different combinations. And that gets all figured out, and out comes this ginormous number, which you then can use as a color. So this isn't color like 2 or 3 or 6. This is color 14,861 or whatever it might be the case. That's how you define, or you gain access to those other colors above color 16. And then you just take it from this universe of thousands of colors and you say, I want this one, and we'll plug it into the fourth bucket. And so now whenever you use color 4, it's this new color. So, okay, that's a huge long explanation on color. Why I'm using it here, I'm not sure. So B is 0, and I'm saying, okay, take B as your blue value. So all blue, no green, and no red. And so that's just, oh, but B is 0. So basically 0, 0, 0, which is black. And we're doing palette 1, which is normally color blue. We're saying whatever was in color 1, replace it with this function. 0, 0, 0. Now, if all these three values are 0, you can see that this right-hand side is going to produce 0. So out comes 0 to begin with, which is black. And so color 1 is now color 0, which is black. Okay. Normal or customized. So we can actually customize this. If you've decided to customize, you can start with, you can define the length of your paddle. Your paddle can increase, decrease, or remain constant. Very nice. And I'm uppercasing decrease so that I only have to check for uppercase, as always. If you didn't choose to have your paddle remain constant, then you get to pick a change factor. Okay, your paddle speed, your horizontal ball speed, your vertical ball speed, how many chances you get, and whether or not to leave a ball trail. So this is actually the first thing I want to try. We'll keep the normal paddle of 60. Paddle length, sure, let's decrease. Change factor, sure, by 2. Paddle speed, let's reduce it to 2. And let's make my horizontal ball speed 0.01. 0.1. Vertical ball speed is 0.05. How many chances? Just give me one. No. No. Whoa. Oh. Okay, it still went very fast. Ay, ay, ay. Okay, well, I thought we had something there. Otherwise, here are your defaults. 100D, 281, and 0.1. I'm not sure why your default Y speed is 0.1, but I said normal 0.5 there. That's really strange. Okay. Leave the ball trail. Yes or no? Oh, that's why it asked me a second time, because I chose to customize it, so it asks me. Pop out of the else, and then it asks me again. That's why we had a second time being asked. So that should have been, either this should have been removed, or this should have been put inside the else. Oh well, life goes on. Clear the screen. XFAC and YFAC, I'm assuming, are the speed of the ball. Interesting. Ball X, middle of the screen. Ball Y is randomly between 6 and 474, so anywhere really in the vertical real estate of the screen. X is 5 and Y is 240. I'm assuming this is your paddle position. The middle of your paddle position, which is in the middle of the 480 vertical height. And then we draw your paddle here. So X is 5. That's really close to the left hand of the screen. Excellent. And we're just going to go Y minus your length all the way up to Y plus your length. Okay, so if your length is 60, this will, another bug. This is going to draw a line from 5, 180 to 5, 300. And that's going to be color 5, which is your purple. Okay, if we've chosen to leave the ball trail, then color equals 1. Otherwise, color equals 0. So color, okay. All right. Okay, 0 is black. So if we're not leaving the ball trail, okay, it gets set to 0. Otherwise, we're going to use color 1. I suspect that we'll be erasing using this color. Okay, FAC, another FAC, is 5. Woohoo. Okay. Do. This is the game loop. So B gets increased by FAC. Okay. If B is greater than 58 or less than 5, then FAC equals FAC minus FAC equals minus FAC. Now B is being used to calculate a new color. Why did I use that? So B now becomes 5, which is a few little bit of blue. So a shade of dark blue, I guess, is now color 1. And we'll keep increasing by 5. It'll get brighter and brighter blue. Until it's greater than 58. That's weird. Okay. This is going to give you a shade of blue. This is changing the shade of blue for color 1. And it's going to oscillate. It's going to go up to, it'll eventually hit 60, and then it's going to go down to 0, and it's going to flip-flop between 0 and 60. Okay, whatever. I'm not sure why we're doing that. Then we're drawing our paddle, getting a press, seeing what we've done. Now, if we've hit up, then our YFA. YFAC, but I probably used YFAC up here. See, I had a YFAC. I'm not sure what I'm using it for, but I obviously wanted another YFAC, so why not just leave off the C? Okay, so your speed is how fast your paddle moves. So YFA is how much we should add to your paddle. If you've moved up, then we're actually going to subtract some coordinates from the middle of your paddle. If you're moving down, then we're going to add, and it's just going to, yeah, because we're not looping until in key string is not equal to 0, we're always going to be applying this speed every time through the loop. So you only have to hit up. Your paddle is constantly in motion. You just tell it which direction. Okay, if your absolute value of your speed Is if your absolute value is greater than 0, then erase. Then yes, we are going to erase. Oh, I see. So if you're moving, then this erase variable gets set to yes. I guess I didn't want to erase your paddle if you weren't actually moving. And you ask, well, how is it that you can be not moving if you're always moving? I just said you're always moving. I think at the beginning of the game, you are stationary. And so I guess it was blinking too much. All right. So we refrain from erasing if you're not actually moving. That's a nice check. Okay. And now let's just throw another random variable, g equals 0. Okay, y is the length of your paddle. If it's greater... Oh, no, that's how you... Okay. That's another way you can stop, a more probable way, if you hit the bottom. So if you're greater than 479 minus your length, and you're going in the positive direction, which is down in our coordinate system, then YFA equals 0, G equals 1, and erase string equals no. Okay, and similarly, the up top. Now I'm checking for y is less than 1 minus 1 plus length, because remember, y is the middle of your paddle. Yeah, and okay, so if you're at the top and you want to keep going up, you can't. We're going to stop you. Erase becomes no, and this magical, mysterious G becomes 1. Circle, we draw the ball using color 5. Oh, no, that's color 12. Radius 5. For ZZ equals 1 to 100 here. So now, this should work. That's what I was hoping for. Ha! It's Pong! You can tell that there is some blinking that happens when I'm moving. Whoa. So this ball is getting faster. And I don't know if you can see it, but my paddle is getting shorter. And it looks like I have a score on the side. This is the proper experience. Now things are getting kind of fast and wonky. Oh, got to 16. Okay, nice. All right. Okay, erase equals yes. Okay, so we wait. We draw the ball and we wait. If we want to erase, then we erase your paddle in color 0. Okay, that's fine. Add the speed that your paddle is moving at. Y2 equals Y2 plus YFA 2? What in the heck? Where is... This is maddening. Okay, YFA2 never existed before this moment. and I may add, what is Y2? We've never actually used Y2. We have X and Y for my paddle, and we have ball X and ball Y for the ball. What are we doing with Y2? What in the world is that? You know, I just suspect if I take it out, we're going to find that the game runs exactly the same. G. Well, that's pathetic. If I had a dunce cap for myself, I would wear it. Okay, I can't exactly exit, so I'll lose on purpose. Okay, well... Okay, these are bounds checks just to make sure the ball stays in the screen and he's bouncing off things. So, XFAC and YFAC are your ball speed, basically. Now this, so if he's over to the right, if he's past the right or less than or equal to 6, then we're going to call that up. Oh, sorry, that's not right. That's up and down. So if he's hit the bottom or the top, we're going to negate his speed, which will cause him to start going in the other direction. So he bounces off the top and the bottom. If he's greater than 634, so he will also bounce off the right. Now, it's the left hand of the screen that's the issue, because he's either going to not bounce, in which case you lose, or he's going to bounce off your paddle. So if he's less than 20 and the absolute value of the middle of your paddle minus his Y position. So if the difference in your Y position to the middle of his paddle, of your paddle, is less than the length of your paddle. So as long as he bounced off your paddle, or ball X. What? Ball X is less than 11 and G, this stupid G variable. What in the world? All right. I think okay, so here's the explanation. If the ball is within 20 of the left side of the screen, and it's detected that your paddle is there, then we will do all this. Now there's another condition as well. Wow. Okay. I'm not sure what this condition is saying, but if he's really close to your paddle and G equals 1, oh, forget it. We'll come back to this second condition. If he bounces off your paddle, what are we going to do? Well, we're going to, first of all, erase your paddle. Okay? If xfac is less than 0, then xfac equals xfac minus speed. If xfac is greater than 0, then xfac equals xfac plus speed. Okay, so if you're his x, wait a second. Oh, no. X and Y speed, they're up here. I was thinking, what in the world kind of more bizarre variables do we have? But we actually said the horizontal and vertical ball speed change is what the X speed and Y speed are. Okay, so they start out at 5, I think. Is that what they... In the non-customized version, it's 1 and 0.1. Okay, so you successfully hit the ball. Then what we're going to do is we're going to change the X and Y fac, the speed of the X and Y fac. And to do that, we have to add X speed and Y speed, respectively. But we don't quite know at this point in time if he's, or at least I wasn't sure at this point in time if I was actually moving to the left or to the right. I guess there was some play in there where if I was right on the 20 pixel line, that maybe I was still technically moving to the right or to the left. So it looks like I just said, look, if you're moving to the left, then your x-fac right now is negative because you're moving to the left. I want to increase the absolute value of your x-fac, so we'll do that by subtracting x speed. But if you're moving to the right, your x-fac is already positive, and I want to up that. So basically what I'm doing here is I'm increasing the absolute value of x and y-fac. I'm just deciding whether to subtract it or add it, depending on the sign of x-fac and y-fac. So I do the thing with the x-fac, and then I just negate it. I do the thing with y-fac. I don't need to negate it because I haven't bounced off the top of the bottom. Okay, then score equals score plus 1 because I'm awesome. We're going to print the score in the top left. Now, if I've chosen to decrease my paddle every time, then the length of my paddle gets decreased. Oh, I can actually increase the length of my paddle? I guess that was one of the options. Okay. Color equals color. If I've chosen to leave the ball trails on, then I'm going to go to the next color. If color is 16, then color equals 1. So color keeps cycling between 1 and 16. But wait a second. All the way up here, I did this funky calculation with color. Oh no, I've changed. So I've taken the function. So color 1 is always going to be a different varying shade of blue. But I'm cycling through all the colors 1 to 16. So as I keep looping over until I get to color 1 again, it's going to be an ever-increasing shade of blue. We'll have to check for that. That's really weird. Well, let's see. Let's see if I can do that right now, just quickly here. I'll just start out with color being 15. Okay, let's do that. Normal, yes, leave the ball trail. So there's my color 15. What? I got that totally wrong. That is the coolest thing in the world. Wow, this is going to require a lot more investigation. So when it's color 1, you get this weird, cool, like, thing. Okay, but we're way over. In an attempt to not bore ourselves to death, we'll call it a day here, and we'll hopefully finish off the one player next time. But we have got to investigate that glowing blue ball trail, which is awesome. Okay, thanks for joining me in this adventure in old code. Have a nice day, and we will see you next time.